Hello and good morning, CTS267 Section 840 students for the spring 2017 semester at Anne Arundel Community College. This is the CCNP TSHOOT course, and this morning's video tutorial is going to be a quick review and augmentation of the Cisco Learning Labs activity Discovery 01 for the TSHOOT curriculum. And so as you can see here, not too much information other than the fact that we've got access to PC1, which is going to have network access to at least one other device. And so when you look at the procedure, you'll see that we're going to be telnetting, but then we're going to be walking through the topology and basically building what the topology is going to look like based off of information that we're going to collect. And we're going to talk about CDP, we're going to talk about logging, configuration archives, and some other very useful tools when it comes to trying to learn things about your network. So let's go ahead and dig in here. We're going to be on PC1, so let's go from, and again, this isn't really a PC, this is an iOS on Linux device. So if I were to say show IP interface brief, you can see that we've got interfaces here, one of which, Ethernet 00, is configured and in the up status. So let's start out by telnetting over to the router that they're asking us to jump onto, 10.10.21. And I believe the password is Cisco, and it is, so there we go. And so then the enable password is also Cisco. So let's start by taking a look here again. This is kind of CCNA level material here initially, and then we're going to ramp it up. So show version, a command that you should be very familiar with. And let's get the, where is our ink to go tool here? Not sure what happened to that. Looking for the drawing tool that I typically use, and I don't see it. I don't see it listed here. I may have gone right by. There we go. Went right by it. All right, ink to go. All right, so let's take a look at some of the information that we have here off of the show version command and some of the things that are going to be important as we start talking about troubleshooting. And so we'll say, remind me later for that. And so let's come down here. So we see the iOS version, right, or the software version. Now this is going to look a little different because this is IOL, or iOS on Linux. And so I'm going to show you what it looks like in a real router here in a second. So you can see that we're running version 15.1. It's i86bi Linux Advanced Enterprise Experimental. And so this is how they simulate the Internetwork operating system. So important information, the uptime. So how long has router 1 been up? Well, it's been up for 5 minutes. The system restarted at 06:13:32 Pacific Standard Time, Sunday, February 5th. And again, if we look up here at my clock, you can see that my clock right here 5 minutes ago, or a little more than 5 minutes ago, would have been right around this time here, Pacific Standard Time. We've got the boot system image file listed here, and the last reload reason is unknown reason, right? So it's not clear as to how this restarted. Then we get some processor information, Intel x86 processor. We get the 200 and looks like 56 megs of memory, 4 Ethernet interfaces, 16K of non-volatile RAM, and the config register value here. Now, don't let this fool you. Typically, and what you should see is 02102 when we're looking at real equipment. If you're familiar with the password recovery procedure, the config register setting is 0x, I think it's 2142, and this basically says ignore the startup configuration and just simply load the default configuration. So it's going to ignore what we have in the startup config. So here's some important information again, all sort of low-level information. Let's pull up a real Cisco router here, and let's take a look at actually router 11 here. And on the ISRG2s, and let's get this information entered in here. All right, so if I were to say show version, all right, you can see we're going to get a little additional information here, specifically around licensing as we get toward the bottom. But again, we can see software version 15.5.3 M4A. right? You can see when that image was compiled. You get the bootstrap image. So the router uptime is 2 days and 6 minutes. Return to ROM by a reload. And again, right here you can see last reload was a reload command, and the last reload type was normal. So that means we executed a reload. Here is the boot system image variable that we're using, is C1900, and you can see this is the iOS binary file. Let's clear the screen here and go down a little further, and let's just keep going here, and we're going to be able to see, and there's our config register setting, right? And so this means, you know, read the startup configuration when it boots X0X2102. And again, the licensing information here with the ISR G2 series, which is the 1900, the 2900, the 3900, you can see that what licenses do I have on this router. So I've got the IP base K9 image, and it's permanent. We've got the security K9 image, and it's permanent. We've got the data K9 image. So if I wanted to do MPLS, I need to have that data image. Again, the security image, if I wanted to do any type of crypto, ISACAMP, IPsec, tunneling, static virtual tunnel interface, I need to have the security K9 license, and the IP-based K9 gives me access to my routing protocols. We get the serial number of the router here. If I go back up a little further, and let's go ahead and clear the screen here. If I scroll back up a little further, again, this 1900 actually has 2 compact flash cards, one in slot 0 and one in slot 1, one that's 512 meg, and the other one is 128 meg card, and you can see that it lists out the sizes of those cards. We've got 255 kilobytes, right, of NVRAM, and we've got the processor ID number, and then you can see here we've got the memory totals here. Okay, so that's our show version output. So let's go ahead and scoot past that, and let's pop back over here to the activity that we're taking a look at. So again, it's definitely going to differ, the output that you're going to see if you're looking at IOL, right, or the Cisco Learning Labs activity, compared to what a real router is going to be providing to you in terms of detail. All right, so the next thing that we're going to do here is we're going to take a look at CDP, or the Cisco Discovery Protocol. Now, a couple quick notes on CDP. Remember that CDP is a layer 2, a data link layer protocol. So if I say show CDP, now they ask you to do show CDP neighbors, but let's just start out with a show CDP first, and let's see the information that it provides. You can see that we're sending CDP version 2 advertisements. There was a version 1 long time ago. The packets are sent every 60 seconds, and the hold time value is 180 seconds. Now, there's a lot of things that you can do with CDP. You can actually facilitate what's called on-demand routing, or ODR, and you can actually route traffic using, oops, sorry about that, you can actually route traffic using CDP. Let's bring that back here, show CDP. So there we go. So you can actually route traffic using CDP. But again, CDP is proprietary. The non-proprietary version of CDP is LLDP, or the Link Layer Discovery Protocol. And we'll enable that on a Cisco device. So if you had non-Cisco devices and you wanted to see that layer, the information that this Layer 2 protocol is going to provide, you would turn on LLDP. So if I were to jump back to just a regular Cisco router, and let's come over to a switch. It's going to give us a little better view here. So if I say show CDP, again, you can see that the settings are the same. Now, what's interesting, if I go into global config and I say CDP question mark, CDP question mark, you can see that here's where we can manipulate those timer settings. So you can see, I'm just going to say advertise V2, which is what I'm doing by default. So that's our default. The hold time, right? I can specify the hold time in seconds. If I say CDP run, that's at the that's going to go ahead and enable CDP, right? There's CDP enable, which is at the interface level, and then we have CDP run, which is going to be global. Now, by default, CDP is running. In fact, you saw when I just said show CDP, that it's definitely running. And then we could tweak the timer value. So let's say I'm unhappy with the hold time. I want to set the CDP hold time, and we're going to set it to, let's say, 45 seconds. And I'm going to set the timer to 15 seconds. So I'm going to shrink the hold time and the frequency at which packets are sent with that timer value. We're going to shrink it substantially there. So every 15 seconds a packet's going to go out. If 3 packets are missed, the hold timer is going to expire, and then that's it. That CDP neighbor relationship is going to go down. So let's go ahead and say do show CDP neighbor, right? And as you can see, ALSW02, which is this access layer switch, has a lot of neighbors. It's got router 10, router 1, router 5, router 8. We see the local interface, right? Now this is a great tool to map your network out. So just from this output right here, I could come over here and I could say, okay, so here's this access layer switch that we're talking about, and this is going to be ALSW02, right? So just from looking at this, I can see that, and actually I went right by the router. So this is a router that doesn't have a name yet, and so we know it's the Cisco 1941. I only have one ISR G2 series, and so this is actually router 11, but again, there's no name on router 11, so we're not going to see that here. So when I look at this, I could say that out 1023, out that port, put here is router 11, right? Router 10 sits out 1022, and of course, obviously this isn't to scale, but you're getting the idea here. We'll come over and we'll do it on this side. So 1013 goes where? 1013 plugs into router 1. And then we've got 1017. So just by looking at the CDP output, I'm able to actually map out my physical connections here. So we've got this access layer switch, and I can see the neighbors it's connected to, and I guess we'll, for completeness here, let's say 1020, and that connection comes over to router 8. And so these are all of the connections that terminate here on ALSW2, and these are the neighbors, right, that CDP neighbors, because they're exchanging those layer 2 CDP packets. And how do they exchange those packets? I guess we'll back up a step. How are those packets being exchanged? They're actually multicast at layer 2, and we're going to see that. I actually have a packet capture already that's got some CDP packets. You'll see the timers. You're going to see the information, right? These capability codes that are being exchanged. Here's that hold time value that we talked about. Now, what is the port ID? Remember, this is going to be on the remote side. So router 11, which we know it's router 11 just because of the platform version here. So router 11, it's going to be at the gig 00 interface on that side. And then all of the rest of these are the fast Ethernet 00. So I would know that this is FA. Oops, sorry, FA00. And again, FA00. And so just using CDP, it's a very, very powerful tool. We get all kinds of information here. And so let's make sure we've got our capability codes. So if you look at the capability codes, they correspond with the codes that you see up here. If I was to go to router 11, and again, we look at that, we've mapped out the entire network in terms of connectivity. I know the interfaces that terminate here on ALSW02 and which devices terminate into those interfaces. I know the remote interface. So if I was to step over to router 11, and let's pull the pull the command line back up here. If I come back over here to router 11, what happens if I say show CDP neighbor over here? Well, you can see that router 11 sees ALSW02. So in other words, router 11 is only connected to ALSW02. And we're going to do a couple things. The first thing is I'm going to change the host name here. Let's say router 11, right? Now if I come back over here real quickly and say do show CDP, do show CDP neighbors, are we going to see that name change yet? No, we're not, right? Well, remember here, the hold time is 166. The frequency of CDP multicast is every 60 seconds. So we're going to have to wait for that hold time to get down to around 120. And you can see it still says just router, right? So in 30 seconds, that router, which we know to be router 11, is going to multicast out to, and the MAC address ends in CCCC, and you'll see that when we look at the packet capture. It's going to multicast out its CDP update. We've got 10 seconds here, and that update is going to have the fields that we're going to be looking at here in a second, and we're going to wait 2, 3, and we should have router 11 here. Oh, the whole time went down to 115, still going down. And there we go. Or no, I'm sorry. I went past it. It was this other router. So there's router. No, let me make sure router 11 didn't show. Yeah, router 11 didn't show. All right, so here is router 11, right? You can see that it picked back up and the whole time went back up to 180, and then we came back 5 seconds later and looked at it. But that CDP update has gone out. Now, you'll notice I still have this sort of bogus entry here, because what are we waiting for, right? And this should remind you of something else that you've seen, which are the neighbor relationships, right? Well, the OSPF, as we're waiting for that countdown to extinction, right? As we're waiting for the OSPF timer, the hold time to expire, that bogus entry right here will be in here until the hold timer expires. And that's okay. I mean, it's not the end of the world that we have these 2 entries in here. But again, we'll come back and take a look at that later. Let's come back over to router 11 here, and again, you can see the capabilities. It's just IGMP, right, for multicast at layer 3, and S for switch. Now, it's a multi-layer switch. ALSW2 is a multi-layer switch. So if I was to come over to ALSW02 and say IP routing, right, I've just enabled the routing capability on that switch. But again, let's see, do show CDP neighbors. So we say do show CDP neighbors and take a look, because remember, we lowered the frequency to 15 seconds. So now the capability has changed. Whereas before it was just SNI, the CDP packets are being advertised or re-advertised from ALSW02, and you can see now that we've got routing capability. We see the platform. What kind of a switch is it? It's a 3750. And again, you can see that it's got a much lower hold time value that'll cap out at 45 seconds. Well, it starts out at 45 seconds, and then by the time it gets to 30 seconds, and let's follow it here for a second, so in 4 more seconds, it's going to bump back up to 45, and we'll probably catch it at 44. There we go. And so that is how you can increase the frequency with which those CDP updates are multicast out. All right, let's drop back over here to the activity, and we want to do the same thing. So show CDP neighbors, right? So you can see that the only neighbor is this DSW1. And we know it's a switch, and it's a multi-layer switch because there's the routing capability, the switching capability, and the IGMP capability. We see the local interface, right? So on router 1's Ethernet 01 interface, DSW1 is connected. And then on DSW1, router 1 is connected into Ethernet 02. And so now we are starting to map out the internals of the network and who's connected to whom. So if I were to say show CDP neighbors detail, right, I could add detail on here, and it's going to give us a lot more information. In fact, we see the IP address of DSW1, the IP address that's assigned to DSW1. Again, capabilities, router switch IGMP. We've got the local interface, the outgoing interface, right, or where is this terminated on DSW1 from router 1. It's Ethernet 02. We get the software version information. You can see the advertisement version. If we were doing VTP or not, what's the native VLAN, the duplex, and then again, we see this management IP. So all of this information is exchanged in CDP packets. So I'm going to pull Wireshark up here, and you can see this was router 11 because it just said router. I captured this earlier because I didn't want us to have to sit and wait. If I was to kick this off again, we should see a higher frequency. In fact, let's go ahead and do that because we did change it to 15 seconds. So we'll say continue without saving, and let me get ready to stop it here. So we should see some CDP packets. There's some ARP, some RARP, and there we go. So router 8 just happened to be sending a CDP packet. So let's take a look, and we'll talk about that multicast address which is going to be a static MAC address table entry, right? Because we need to make sure that we reserve it. So the destination here, and this is CDP, VTP, DTP, PAGP, and UDLD, right, are all leveraging this multicast MAC address at layer 2. Okay, and it shows us the source, right? And the source is obviously the device, the Cisco device, router 8. But again, what's the destination? The destination is that this is sent out as a multicast, so it's going to go out to everybody that I could reach at layer 2, because again, I'm sending out CDP information, or it could be VLAN trunking protocol, or the dynamic trunking protocol, or PAGP, or unidirectional link detection, right? UDLD. But again, that is the MAC address that I'm using, and so you're probably wondering, well, wait a second, where is that MAC address? If I swing over here to the switch and say do show MAC address table, where is that at? Well, it just excuse me, just happens to be the very first static entry. Now you'll notice it says ports CPU. Well, what does that mean? Well, what this means is that when frames show up to this multicast MAC address, it's going to interrupt the CPU in order to deal with it, which is why broadcast storms, if we remember, we talk about BPDUs. Well, here is the BPDU MAC address for the spanning tree protocol, right? So we talk about broadcast storms spiking the CPU to 100% or 99% to where you can't even get logged in. And this is why. Because you get these BPDUs that are being flooded, and it's basically thrashing the CPU. But the important takeaway right here is here are those static MAC addresses, specifically, you know, CDP, VTP, PAGP. They're all going to use this multicast layer 2 MAC address, and that's why it is a static entry, and that is in contrast to what we call a dynamic entry. And you can see we've got some dynamic entries down here. They all happen to be in VLAN 1 because we haven't configured any VLANs on the switch or moved these into different VLANs. But hey, here's a port that we should recognize, and that should be the MAC address on the gig 00 interface on router 11. And let's check that out. It ends in California 00 and starts with 80 echo 0. Let's see if that's the case. If I say do show interface gig 00, what is the MAC address that burned in MAC? And lo and behold, there it is, right? So now I've even got more granular confirmation, right? The CDP showed me, hey, FA1023 is router 11, but now I've got some definite layer 2 confirmation here that, yeah, this is exactly what the MAC address table sees, and it's learning it dynamically, right? Which means that when it was plugged in, traffic was generated, it comes up on the wire, and then it's learned, right? It learns based off, and it populates this MAC address table based off the source MAC address. Right? So the source MAC address for router 11 was that value there. So as soon as router 11 sends a frame into the switch says, aha, I know about that source MAC address out that port. Right? And that becomes very, very important when we're talking about forwarding traffic at layer 2. And then last comment will be the all Fs, right? Which again is reserved here, a static entry. And you'll see these on just about every single switch. But again, this is the all nodes, right? This is going to represent all nodes, the all FFFFF. Okay, so that's the Cisco Discovery Protocol. We've taken a look at the show neighbor detail. So now let's go ahead and take a look at show ARP. So if I say do show IP ARP, and I don't think we've got anything, yeah, we're not going to have anything there. No layer 3, and I'm not even sure we have anything over here. So let's say do show, and you can say do show ARP as well. Right? And so here we go. We've got the layer 3 address, 192.168.1.1, right? And there is that MAC address, that 80 echo 0, and then we've got the California 00, the burned in MAC address on the local interface gig 00. And so here is the entry that ties these two values together, the layer 3 information being tied together with the layer 2 information. And again, actually, let me take a quick step back here. We were looking at the Cisco discovery protocol, and I just realized I forgot to take a look. So here are the values, right, that come out of there. So you can see version 2, time to live, 180 seconds. Device ID, there's the router name right there, right? What type of device? So there's the hex value that indicates it's a router. 6 bytes in length. We've got the device ID, which is the name, the software version, right? So here's all that information that we're seeing when we took a look at show CDP neighbor detail. The platform, I see it's a 2811. There's the hex value for the platform code. Again, there's the platform. It does have an IP address. Only a single IP is configured. That's what that IP address is, right? The port ID. So here's how it knows the remote port. So again, the port on router 8 is it's connected with fast Ethernet 00, and you can see that it shows that the CDP packet was sent through interface fast Ethernet 00. Here's the capabilities codes, right? Is it a router? Yes. Is it a bridge? No. Is it a source route bridge? No. Can it do switching? Yes. Host? No. IGMP capable? Yes, right? And so there's those codes that RSI that we see. You can see here we've got duplex full, right? VTP information if we were doing any VTP. And again, the key to remember is that information is being communicated using this multicast MAC address. All right, so let's step back. And I apologize there, I'd forgotten to cover the values in the packet. So here we are with ARP, and actually we're going to get some better output over here on router 1. So if I say show ARP, right, you can see that router 1's got all kinds of connections here. Interface 02, you can see we've got sub-interfaces configured, right, 01.50. And again, what we're seeing with ARP, the address resolution protocol, is the mapping of the layer 3 information to the corresponding layer 2 information. And this is what happens sometimes when you ping and the first ping packet gets dropped. Typically, the reason for that is that you have to ARP, that you don't have this entry right here, right? That these entries are missing. So again, as an example, if I was to say, ping 201.1.2.3, I don't have an ARP cache entry for this. Now, if I had a route to this and this IP actually existed somewhere, we're going to send an ARP packet anyway, but I would ARP out for my default gateway, right? So this would force me to ARP out, and there the first ping would be missed, and then if this network actually existed and I could reach it, then the rest of the pings would be successful, right? But again, the reason it's successful is because I ARP out. I send an address resolution protocol out saying, hey, I know the layer 3 information that I'm trying to find. However, I don't know at layer 2 how to forward this traffic. And that's what ARP does. ARP basically says, I know the layer 3, I know the IP address, but I don't know the layer 2 MAC address that I need to use at layer 2 to forward this information. And then again, you can see the combination of that information, the layer 3 IP address and the layer 2 MAC address, then ties me to an interface. Whoops, sorry. Trying to highlight this here. Ties me to an interface out which I'm going to go. Right? And we need all of that information. And I stress that it's great that you've got the IP address, but without the MAC address, you're not going to get very far, right? You're not going to get very far. All right, and so, excuse me. And so now we're going to take a look at show interface description. So if I were to say show interface description, right, you can see that it shows the comments. Now the comments are only as good as the NetAdmin, network administrator, who is entering them in. And they're only as accurate and correct as the individual who's entering those in. So when you look at this, again, it's not this description over here is what we're typing in. right? This is actually what's being typed in by the network administrator. So if I were to go into the loopback interface, right? So let's say interface loopback 0, and if I were to say description, and let's do this. We'll say not used at all. So we'll leave it at that. So then we say do show interface description, and you can see that the comment says not used at all, but the interface is up, and we know that it's being used. So this is what I mean when I say that these descriptions are obviously input by individuals, and there is, human errors possible, so we need to make sure that we're very, very careful. So now step 6 is asking you to verify the topology, the partial topology that we're looking at. And so again, you can draw that out based off of that show CDP neighbors output of that information that we have, all based off of a single device, router 1, right? So router 1 is showing us a ton of information. And so now that we have the IP address, when I say do show CDP neighbor detail, I've got the IP address for DSW1. I know it's 192.168.10.253, so let's do this. Let's exit off of router 1. All right, and now let's say telnet to 192, where'd that go? 192.168.10.253. And let's get rid of the T. All right, so the password should be Cisco, and so we're in, and we'll go from user exec to privilege exec, and we'll say Cisco. And now I'm on the distribution layer switch. So again, in terms of troubleshooting, right, it's a great way to map the network out, but with relationship to troubleshooting from a bottom-up methodology, right, and you always want to make sure that you follow a process, is to eliminate all of the layer 2 issues when we're talking about bottom up. So again, all of these commands like show IP interface brief, right, and I see all my interfaces, or show CDP neighbors. And now my topology has just grown, because now I see that there's 2 access layer switches that are obviously multi-layer, right, because of the R bit here, the capability bit that's set in the CDP packet. Excuse me. So now we have 2 additional devices that are hanging off of DSW1. So let's see what they are. One's out Ethernet 02, and the other is out, I'm sorry, not out, wrong, Ethernet 00 and Ethernet 01, and then they're connected on the remote side to 02 and 01. So if I were to say show MAC address table, let's see what we've got out Ethernet 00. You can see we've got a couple of MAC addresses that we've learned. And so typically, what would that indicate to you? You can see we've got VLAN 50. We have 3 distinct MAC addresses here coming in off of VLAN 50. In fact, there's a 4th one up here for VLAN 50, but it's coming in Ethernet 02. And so typically that indicates that we may maybe have some sort of a trunk link, right, between this distro layer switch and the access layer, because we're not doing layer 3 at the access. So show interface trunk. And sure enough, take a look at what we've got here. Ethernet 00, 01, and 02, these are all 802.1q trunks. And you can see the different dynamic trunking protocol modes, desirable, on, right? We see the VLANs that are allowed. And for troubleshooting purposes, this is one of the first things that you want to look at when you suspect, or that when you start your investigation. And if you start at the access layer and you're working your way toward the distro layer and then toward your core, to make sure that the VLAN in which the host sits, that VLAN's traffic is allowed over the different trunks. You can see here that Ethernet 01, that nothing is allowed, right? That no VLANs are in the spanning tree forwarding state. Okay. Excuse me. So actually, let me correct that. So VLANs allowed are 10 and 50, but which ones are forwarding? None of them are forwarding, right? So we have this allowed statement, but then none of those VLANs are being forwarded over Ethernet 01. So again, show MAC address table, show CDP neighbor, show CDP neighbor detail, all of that information. And we'll say show CDP neighbor detail, as we'll see there's router 1, and now we're interested in ASW1. So here's the management IP for ASW1. ASW2, There's the management IP for ASW2. And again, we see all of this additional information. We find out the version of software that's running, and we can see exactly who is connected to us. All right, so now we're going to dig a little further into the MAC address table, right? And we talk about the dynamic and the static entry. So we're now going to bail out of the distro layer switch, and let's telnet to 192.168.50.100 with the password of Cisco, and then enable password of Cisco. All right, so now we're in privilege exec. So let's start at the bottom. Show CDP neighbors. So who does ASW1 see? Well, he sees ASW2 out his Ethernet 03 port, and he sees DSW1. And again, these are all CDP generated. This is all CDP generated information. I could say show CDP neighbors detail, right? And it's going to give me even more information. So now that we've got that information, let's say show MAC address table. And we can see that we've got devices connected up on, and we'll look at VLAN 50 here, Ethernet 02, 00, 01, 03, two things coming in on 03, or two MAC addresses being learned, I should say, and then a second MAC address being learned on Ethernet 02. And so again, what that tells us is that there are probably multiple connections out that interface, or the multiple devices that are existing out that interface. So one of the things that it asks us to do is to ping the broadcast address for the 192. So let's ping 192.168.50.255. And what this is going to do is this is basically pinging the broadcast address, and so we should get responses back from anybody that's out there. So it looks like there's a 254 address, a .10, a .20, a .110, a .30, and so you see we start to get these responses back. So now if I were to say show ARP, right, you can see that we have the layer 2 information, right, the MAC address for, or that corresponds to, the layer 3 IP. And so again, that's that ARP cache. So now when I go to send traffic to any of these IP addresses, I know the layer 2 address, right? And here we can see the interface is going to be VLAN 50. I know the information that's going to be required at the switch level in order to send that information out. Now they have us do much the same thing over on ASW2 on step 12. I'll leave that to you, but again, it allows us to one more time start to add additional devices in that we didn't know about before. And using all of these layer 2 methods, the show CDP neighbors, show CDP neighbor detail, show interface trunk, show IP interface, well, I shouldn't say show IP interface brief, that's layer 3, but you get the idea. And the show MAC address table, right, is sort of taking that layer 2 information, allows us to map out the network. So now it's asking us to shut some interfaces down, right? So interface range Ethernet 10 to 3, comma Ethernet 20 to 3, and then comma Ethernet, what does it want? 30 to 3, 30 to 3, and then, boy, it wants 40 to 4, Ethernet 40 to 4, and then Ethernet, 40 to 3, sorry, 40 to 3, and then Ethernet 50, oops, sorry, 50 to 3, and then to basically say shut, and just to shut down unused ports. Now, obviously, this is a best practice. If you don't have anything plugged into the port, you want to shut the ports down, right? So what about a show interfaces description? What are we going to see now? Show interface description. Do show interface description. And there you go. You can see that they're administratively down. And we've got some nice comments here, right? Connected to PC3, connected to PC2. So I know that there's two PCs that one hangs off Ethernet 00, the other off of Ethernet 01. And then I've got my connection to the distribution layer switch. We've got a loopback address, VLAN 1 and VLAN 50. All right, and then it asks you to update the descriptions on DSW1. I'll leave that to you because you can just go ahead and type in meaningful descriptions. So then it talks about NTP and how critical NTP is, and I can't stress this enough, that if you get into a troubleshooting situation and you don't have accurate time, it is going to be extremely difficult to troubleshoot. So you can see here that we've got, looks like 2 NTP associations, so show NTP status. We should be synchronized. Yep, so stratum 9. So by looking at this, remember stratum 1 is going to be some sort of an atomic clock or a GPS clock. And the default for Cisco devices, if I were to just simply enable NTP on a device as a master device, it's going to be stratum 8. And so as you move away, right, or you go a hop away from the NTP server, the stratum number increases. So my guess is, just by looking at this, when you see stratum 9, that you are 1 hop away from a stratum 8 device, and that device has been configured, and you can see here it's 5254. So how would we figure out where that's at? So again, what if I say show ARP? I'm trying to figure out the interface I'm learning time on. So here we go, show ARP. There is the layer 2 to layer 3 information. I know I'm learning it from VLAN 50. What if I say show MAC address table now? Because I have the MAC. So here's the MAC, 2 delta 10. So let's come over here. Aha, 2 delta 10. So there it is. I know it's out Ethernet 02. So now let's go up the food chain. Show CDP neighbors. So who's out Ethernet 02? Bingo. Distribution switch 1. So if I were to go back to distribution switch 1, and that's going to be telnet 192.168.50.254 Cisco, and then go to router 1? No, that shouldn't be router 1. I put the wrong IP in, I believe. Let me double check that real quick. I got to get the IPs. Oh, yeah. So it shows that R1 serves as the NTP master, and the other devices are pulling time from router 1. So yeah, let's take a look at router 1 here. Say enable and Cisco. And so if we were to look at show run section NTP, you can see that it's configured with the NTP master command, and the stratum by default will be stratum 8. Right? Because I didn't put anything here, because what I could have said is NTP master and then put a stratum number down. So what if I put 2? Right? Then all the devices downstream, or the devices that are a hop away downstream, would be, they would see it as stratum 3. All right. Excuse me. So we're on router 1. We need to be on router 1, because if I say show log, right, which stands for show logging, you can see that this is the buffered log, right? So this is actually writing to the RAM on the physical router, and it's saving these messages. And so let's talk a little bit about some of the default settings. You can see that up here at the top part of the output, and let's get the pin tool going, we've got, are we logging to the console? Well, we would be doing it at the debugging level, but you can see, excuse me, that XML is disabled. We've got 14 messages that have been logged, and filtering is disabled. What about monitor logging? So what is monitor logging? Well, this is when you're in a VTY line. So if you've SSH'd or telnetted, right? Telnet to the device, monitor logging is going to reflect what kind of log messages you're going to see. You can see 0 messages have been logged. Filtering's disabled. We've got buffer logging, and this is when we do show logs. So let's put this down. That buffer logging is when I say show log, and it's buffering these log messages and saving them. And you can see we've got the same 14 messages have been logged. Trap logging, right? It's at the informational level. And we talk about the alert, the warning, the informational, the notification, and what messages are going to be logged. Now, it kind of scrolled by here. I don't see it in here, but there's a default. And the default varies by platform. Let's focus on buffered logging for right now. Right? So if I were to pull up a real Cisco device, and let's say we're on router 11 here, and actually so we don't have to enter the password in. Let's come back over. Let's come to the switch. If I were to say show logging, right, you can see that we've got the log buffer. The default setting is 4,096 bytes. Now, generally that's going to be around 50 lines of output. Remember, a byte is 8 bits. So 1 byte is going to be a character, right? A single character. Well, we're saying that we're only going to hold on to the most recent 4,096 characters in the log. And that's not a whole lot, right? You can see the interfaces, we're tracking the interface status and things like that based off of the level at which we're logging. But you can increase that logging buffer. And so let's see how you would do that. So I can say logging buffered, and here are the different severity levels. Okay. Now, quick note here on emergencies, severity 0, and alerts, or maybe even critical, 0, 1, and 2. There's a very good chance that you're not going to see this pop up on your screen, maybe, right? You may catch it, but typically if it's something that's wrong at the emergency or at the alert, or the immediate action or critical, is that the router or the device may be having so many problems that it's not able to generate the message, right? Or it's so severe of a problem it can't generate the message. So, but here's what we're going to do. I'm going to say logging buffered, and we're going to drop it all the way down to informational, right? So remember, the buffered logging earlier, you can see here buffer logging was, the level was debugging, which means I'm going to log at the debug level and below. And by below, we mean the lower numbers. So 765, 4, 3, 2, 1, and 0. Well, if I don't want that, let's say I just want to do logging buffered, and I only want to see the informational messages. I can say informational, and actually, before we do that, you can do it in one command. I'm going to say 512,000. Right? So that's definitely a step up from 4,096. I'm going to say 512,000. And then I can put in the alert level, and I can actually use the word informational, or I could have just simply said 6. Right? It'll allow me to put that in there. So now when I say do show logging, excuse me, we take a look here, you'll notice what happened. Exactly. When I changed the buffer size, it completely wiped out what was there. So that's typically why when you're setting logging up on a device, you want to do it when the device is deployed. Now, if I want to send these messages to a syslog host, I can say logging host, and let's say 192.168.1.150 is who we're sending that information to. I could do that as well. Now, the information that we see, so if I was to say, let's say I'll say clear counters, this will generate a log message. And you can see here's the syslog facility, and along with the message that we get, and I just basically said clear counters. So now if I say show logging, we should see, there we go. And this tells me the level of severity of the syslog event. And again, when I did that logging host command, these messages are going to be sent out to a remote host. Now, if I want some more detailed information, we talk about the service timestamp. So I say service timestamps. Now for logging, right? I can do it for debugging as well, but we'll say service timestamps log. I can say date time, and I like date time. Uptime is very, very difficult because everything is being referenced, or the point of reference for the uptime argument is the amount of time since the router came up. And that is sometimes very difficult to follow. So I say service timestamps log, date time, and I like to max out everything in my log. So I want milliseconds, I want the year, I want the time zone to be shown. And so when we say do show run, section, and actually let's just say include service, you can see that we've got a lot more information. So now when I say clear counters and then show logging, we should see that we've got a little additional information, right? So here's UTC, right? You can see down to the milliseconds has been added. It wasn't up here. Now we've got milliseconds being shown. We've got the time zone being shown, right? So we've got a lot of different information that's being shown here. And so that is really, those are sort of the basics. You can change the level of logging. Again, if you telnet in for the terminal monitor command, to be able to show you messages while you're telnetted or SSH into the device. A couple of other things that you might want to add in is service, and is it user info? Where is it at? No, service line number. No, that's not it. Counters. Service counters is the one I think I'm looking for. Or no, that's not it. I apologize. Yeah, there's one of these options here that actually gives us additional information. Sequence numbers. There we go. Service sequence numbers, right? So when you say service sequence numbers, if I say in, we'll say clear counters, and there we go. And you can see service sequence numbers will tag with a numeric value in increasing order the messages that you have in your log. Now you see it didn't do it initially, but now take a look, and we continue to build on the log. And when we get into the archive facility, which is going to be coming up here in one of the modules, we're talking about restoring configurations. It's nice to be able to see these in sort of a numeric order, because when you go to trim the output down or maybe select a specific event, you can actually just grab off of that. So if I was to say show logging and then include 0258, I get that single line, right? And again, it makes it a little easier to read, and you still get the same information. So, all right, well, that is going to wrap up Discovery Activity 1 here in the Cisco Learning Lab section. Again, kind of going over some material that we've already covered before, but it's very good to review it to make sure that we're ready to go when it comes to being able to troubleshoot, and especially when we're talking about using that bottom-up approach. All right, thanks so much for watching, and I will see you guys on Thursday night.